Hello, friends. Today we'll be starting with a different course. The topic for today is kinematics. Let me outline the course details today. We'll be discussing here. First of all, we'll be learning about kinematics, like what is kinematics, what is the definition of rest and motion. We'll be discussing the differences between the distance and displacement. After understanding the differences between distance, displacement, understanding the concepts of rest and motion, we'll be talking about average speed and instantaneous speed. Next topic will be average velocity and instantaneous velocity. And at last, we'll be talking about average acceleration and instantaneous acceleration. Let us start understanding the definition of kinematics. What is kinematics? And why is it so that we are talking about rest and motion when we are studying kinematics? Please understand, kinematics is the branch of mechanics where we talk about a body at rest or in motion. Let's assume a car resting at point A, it is not moving. Now, observation of this car, if we talk about the mass of the car, if we talk about the gravitational pull or the weight of the car, this is a part of kinematic. In situation number two, if the car starts moving with a constant speed of 20 meters per second, and after some time it reaches to another point, which is point B, and at point B again the speed of car is zero. That means after reaching B it comes to rest. So discussing about the situation where the car is at rest at A and it starts moving with 20 meters per second, and then again it stops at B, we are talking about the motion of the car, but we are not discussing anything about the cause of the motion. What could be the cause of the motion? We start the car, we try to accelerate the car from 0 to 20 meters per second. There is certain force involved in order to move the car from rest till it reaches point B. But when we are not talking about the cause of the motion, when we are not talking about the forces involved, again we are talking about kinematics. Now, after understanding the basic definition of kinematics, we have got two terms here, which is rest and motion. Well, in general, we can simply say that anything which is not moving is at rest, or anything which is not at rest is definitely moving, or that body is in motion. But what should be the technical explanation of rest and motion? Is it only that simple that if it is not moving, it must be at rest? Let us try to understand this. Understanding the concept of rest, rest is always associated with a body which is not changing its position. Now, when we talk about position, we are living in a three-dimensional world, and we define the position in X, Y, and Z form. Let's say this is the position of the body. There is certain coordinates that this position has got. Let's say this point is A, and the coordinates are X, Y, and Z. Now, if the body is not changing the position, the body is said to be at rest. But is it really at rest? Let's think over it one more time. The person who is declaring that the body situated at A is at rest, what is the position of that person? Let's say we have a table, and on that study table, we have got one cell phone. Now, you can clearly see that this cell phone is not moving, but this cell phone is not moving according to a person who is situated nearby to this, who can actually see this phone. And according to this person, this phone is not moving. But let us shift the position of this person and let us take this person to another planet, or let's say to moon. Now, since this table is situated on the surface of Earth and the Earth is rotating, this person will find this phone not at rest but in motion. How is it possible that an object which is at rest, the same object is in motion for the person if the person is changing its position from from the similar planet to another planet? From here, we can clearly understand that rest and motion, these are the combined property of the object under study, which is the phone in this case, and the observer. Can we define anything at rest or in motion without the viewer or the observer? No. So we come to a conclusion that nothing is in absolute motion or in absolute rest. Now let us see one more real life example to understand the concept of rest and motion, to justify the statement that nothing is absolute rest or nothing is in absolute motion. Let's say in New York City, there are two persons who are moving in negative x direction. But suddenly, a police officer comes and is asking this person to stop, to freeze. Now, just think about this. The position of these two persons and the position of this police officer. This position is defined on the surface of Earth. And according to this police officer, these two persons or any other person who is actually situated nearby on the surface of Earth, you'll find these two persons at complete rest. But suddenly, this position of police officer is now changed and now he is on the surface of moon. When he is on the surface of moon, he is going to find these two people moving with certain speed. And what could be that possible speed? That speed would be equivalent to the rotational speed of Earth. Because for this person who is now situated on the surface of moon, will find these two persons as a part of this Earth which itself is moving. This example again justifies that motion is, there is nothing called absolute motion. This depends on the frame of reference. The frame of reference of the observer or the viewer. My friends, I think we understood the concept of rest and motion with the help of these examples. Now let us move forward to the concepts of distance and displacement. Now, what is distance? In order to understand the distance, we should understand that distance is always associated with a journey. In order to have certain distance, we need to travel from one point to another point. Again, we are going to assume a car situated at point A and it starts traveling, and after a certain time it reaches to point B, changes the direction and moving in another direction and reaching the destination, which is point C. In order to understand the distance, we need to find the total path length. What is the length of the total path of the journey? We can clearly see that the total path is AB plus BC. So the distance is the total path length of the journey. It is different from displacement being a scalar quantity. Now, what is a scalar quantity? A scalar quantity is something which has magnitude, but it does not require any direction to define that quantity. For example, here if we want to define the distance, if we want to understand what is the total distance covered by this car, so we're going to say that the car has traveled from A to B and B to C. The total distance would be what? AB plus BC. But did I mention any particular direction in order to, while defining this distance? No. Let's say that this final destination of the car is nearby to a school. Now, if we want to define the distance, which is AB plus BC, do we really need to mention the position of the final destination, that it is actually nearby to a school? No. Do we really need to define the direction of journey, that from A it is moving in north direction and then it changes itself and the direction changes itself to what, northeast direction? No. So in distance we only talk about the magnitude, but what is displacement? Let us try to understand the concept of displacement with the help of same example. A to B and B to C. Let's say this is 10 meters and this over here is 15 meters. What is the value for the distance? The distance traveled is 10 plus 15, which is 25 meters. But is it same for displacement? Is displacement 25 meters? No, it is not. Because while understanding the concept of displacement, we need to first learn about the vector quantity. Displacement is a vector quantity and it requires a particular direction to define that quantity. You can clearly see that this car is not moving in one particular direction. It has changed its direction while traveling from A to B, then to C. So displacement must be defined from A, which is the starting point, to C, which is the destination. So if you connect the starting point to the final point with the help of a straight line and an arrowhead, we get the displacement. Of course, we can do some mathematics and to find, and we can clearly find the easily find the value for this, which is AC. But displacement over here is going to be AC. Now, we just learned that displacement is a vector quantity, and vector quantity includes magnitude as well as direction. The magnitude for displacement is AC, but what about the direction? The direction is from initial point to final point. What is the exact value of AC? Well, we can find the value of AC by using the triangle law of vector addition. We'll be discussing about the vectors and different rules and laws of vectors in my next course. You can find this topic and explanation and a theoretical explanation of these topics on my website. Okay, I hope you understand the differences between distance and displacement. Let us try one real life problem and try to find an answer for that problem, which actually sharpens our concept, which sharpens our theoretical understanding of the same topic. Okay, now Rocky did really well in his class 11th and class 12th, and he got admitted to one of the prestigious universities of the world. But Rocky is a versatile. He's an all-rounder student. He also likes to uh, play sports, and he's a good athlete. So on one fine morning, he found himself really curious about the playground of that particular university. So he rushed towards the playground, and he started observing the field. Now, in general, the circumference of the playground, if we consider the playground to be a circular shaped field, the circumference is 400 meters. Let us say that the Rocky is standing at point A. Now, he starts running clockwise, and after three 3 by 4 complete rounds, the new position where he is landing himself is somewhere here. Now, the question is, what is the total distance covered by him in 3 by 4 revolutions. And the second question is, what is the magnitude and direction of the displacement? Okay, so first of all, let us try to find the distance covered by him in 3 by 4 rotations. Now, what is 3 by 4? 3 by 4 simply means 3 complete rotations, and after complete 3 rotations, he's going to travel 3 parts. If we divide the whole field into 4 equal parts, if we divide the circumference or the periphery of the playground in 4 equal parts, so he has actually covered 3 complete parts out of those 4 parts. So the position is here, which is B. Now, according to the definition, the distance covered, the distance is always the total path length of the journey. Now, total path length means he has traveled one rotation. Okay, he has covered one revolution, which is equivalent to 400 meters. Second revolution is again 400 meters. Third one is again 400 meters. And the last one is 3 by 4 of 400. What is 3 by 4 of 400? It is 300, because I think you clearly understand that 400 can be divided into 100, 100, 100, and 100. So 3 parts of 400 is 100 plus 100 plus 100, which is 300. The total distance is what? 1500 meters. So we can answer this question and we will write the answer as 1500 meters. Now, what about the distance? Oh, I'm sorry. What about the displacement? Well, displacement, try to recall the definition of displacement and how displacement was different from distance. Displacement can be found by connecting the initial and the final point. Displacement is a vector quantity, which says that we need to have a particular direction in order to define displacement. What is the initial point? The initial point is A. What is the final point? It is B. So the displacement will be this part, which is 100 meters. No. Please make sure while finding the displacement, you are connecting the initial and final point with the help of a straight line. It is not just about connecting the initial and final point. It is also about a straight line, because we are talking about one particular direction. We are talking about the vector quantity. So we're going to use a line, a straight line, starting from the initial point and connecting it to the final point. Now this arrow, the length of this arrow is going to give us the value for the displacement. Now, we are going to do some mathematics to find the exact value, the magnitude for AB. Oh, well, we can clearly see that the circumference of the periphery length of the ground, of the playground, is 400 meters. So 400 meters is equal to the circumference one more thing over here, I just want to discuss that for the educators, it is really simple to finding the answer and doing all the calculation. But as a student, one actually struggles that where to start. Now, I'm going to give you a trick over here. When we are asked about the length AB, so you need to ask yourself that what are the given data. The given data over here is 400 meters, which is the periphery, the length of the periphery, this thing over here. And in order to find this length, let's say this is L, we have got one option which is using the Pythagoras theorem, because we can clearly see that triangle AOB is right angled, which means 90 degrees at point O. We can use Pythagoras theorem to find L, which is L squared, which is the hypotenuse, is equal to OA squared plus OB squared. In order to find this L, we must know the values for OA and OB. So I'm just trying to find the value for OA or OB, both are equal, which is the radius for this circle. If circumference is given to, now just try to look at the given data. Circumference is given to us, and what do we need to find? We need to find this R. Can you find any connection? Can you establish any connection between circumference and radius? Yes, you can. Circumference basically is what? Circumference is 2 times pi times r. From here, we can write r is equal to 400 divided by 2 pi, which is r is equal to 100 over pi meters. OA and OB are same, so we can write this as r squared plus r squared. So L squared is equal to R squared plus R squared, which is L squared is equal to 2R squared. From here, we have already found the value of R. We just need to put the value of this R over here to get the value for this displacement, which is L. I hope with the help of this example, now you are very much clear about the differences between distance, displacement. What if you are asked a question on distance, to find the distance and displacement? After this, let's do a problem on distance. A very simple problem we are going to pick. So we have a stone which is spherical in shape, not a perfect sphere, but yeah, we cannot have a perfect sphere for a stone. Now this stone starts its journey from point A and it stops point B. Now what is the value for the distance covered by the stone? What is the magnitude of distance? Well, distance is nothing but the total path length. So we are going to use a measuring tape or any such device to measure the total length from point A to point B. But is it going to be a straight line? No, because while discussing distance, while calculating distance, we need not talk about one particular direction. We just need to follow the journey. We just need to follow the path covered by the stone. So we are going to measure the distance something like this.